So we've talked about blood biochemistry and how we can use blood biochemistry to determine where blood comes from and who it belongs to. So now let's talk about some blood physics and see if we can work out how the blood got there. So what we're going to do is take a look at some blood patterns and see if we can reconstruct the crime from the pattern of the blood. So if there's blood on the suspect, from looking at how the blood is distributed, can we understand how the crime was committed? The technical term for this distribution of the blood on the suspect and the crime scene is called blood spatter. So what we're going to do is blood spatter analysis. So here are some typical marks in blood that might be found at a crime scene. Both of these marks come from the transfer of blood. So in this case, blood has got on an object and then has been transferred to the place where it's found. So the one on the left, for instance, clearly someone has stepped in blood, and this is a partial bloody footprint. The one on the right is a handprint in blood. Someone has got blood on their hand is covered in blood, and then it's been smeared on the wall here. The pattern, the way that the blood is distributed, can tell you about where the blood came from and how it got there. So if in a violent crime an artery is severed, then there will be a very characteristic pattern of arterial spurting. So because arteries come directly from the heart, the pressure in the artery varies as the heart beats, and this means that blood will spurt from the artery. So instead of a continuous flow, you will get a spurt with each heartbeat. And this gives a splash of blood, in this case on a wall, and because it's a relatively large amount of blood coming from the artery, it will then dribble down the wall. This is called arterial spurting. On the other hand, if someone has a much smaller wound, and for instance is standing there wondering what to do, then you will get a pattern of blood drips. Now, the exact pattern will depend on the surface in question and also how long the person stands there with blood dripping into the pool. The pattern created by flying blood will also depend on the violence of the event that caused that blood to fly. If it's a relatively low energy event, for instance, an ordinary fight, then you will get low velocity blood spatter. This can also be from blood that is falling from a wound and also blood that is cast off. For instance, if someone is struck with a weapon and the assailant then pulls the weapon back to take a second blow, as he pulls the weapon back, there will be some blood drops cast off from the weapon, and these would also give you low velocity blood spatter. Thinking about someone being attacked by a weapon, for instance being beaten with a baseball bat, this is a relatively energetic event. The blood that's flying around will move somewhat faster, and this will give medium velocity spatter, as shown in the picture here. The most energetic events would, for instance, be associated with gunshots, and this gives high velocity blood spatter, where you have a lot of small droplets of blood moving very fast, a little bit like a mist. So this is high velocity blood spatter. So by looking at these patterns of blood, the forensic scientist can determine something about what happened in the crime. Now let's consider a falling drop of blood. A blood drop as it falls is roughly spherical, and if it hits the floor at an angle of 90 degrees, then you will get a circular blood spatter mark. But suppose that drop of blood doesn't hit the floor at 90 degrees. Suppose it hits the floor at an angle. Then you will not get a circular pattern on the floor. You'll get this elongated shape. And maybe if the blood as it hits the floor has enough energy, there will be a little splash. So in front of the main elongated shape, there will be a little extra dot of blood that bounced out from the main droplet. So for instance, you may have a pattern like this. So here the blood has come from the left, because you can see the main shape followed by a smaller droplet on the right. In fact, we can correlate the shape of these blood droplets with the angle at which they hit the surface. So when you have a 90-degree angle, we get this circular pattern, and as you go through to a very acute angle, it becomes more and more elongated. So at a very acute angle of 10 degrees, you get this very long blood droplet shape. Now suppose at the crime scene you have multiple blood droplets in different places. We can work out which point in space was the origin of those blood droplets by plotting lines backwards from the droplets where all of the lines cross, which is called the point of convergence. This would have been the source of the blood. Now, when we look at a diagram like this in 2 dimensions, it looks very simple. But of course, crimes occur in 3 dimensions. So we have to do this kind of blood spatter analysis in 3 dimensions. So if we can plot the lines back from the blood stains, for instance, on a wall to a point of convergence, then we know in 3-dimensional space where the crime happened. So in this example, for instance, plotting the lines back from the bloodstain pattern on the wall gives us the height above the floor at which this event that generated the blood happened. So if that height above the floor is, say, 5 feet, then we know the victim was still standing at the time. If that height above the floor is only a few inches, then of course we know the victim was already on the floor when they were being beaten. And this is very important evidence for reconstructing the crime scene. Now, of course, these diagrams we're using here are very, very simplified. And in a real situation, it would actually be much more complicated to work out the point of convergence. In fact, if you have a crime scene with even more blood than this, it may just be impossible because there's just too much blood at the crime scene to be able to interpret the situation.